Hello, everyone. Today, we will focus on exploring the Siemens PLC development environment. The core is to introduce Siemens S7-1200 PLC, laying a foundation for future hands-on practice. Let's first clarify the overall framework, then proceed step by step. First, let's look at the task description. We are going to set up a minimal PLC system. We will connect an indicator light to one of the PLC's digital outputs and use two buttons on the touchscreen to control the indicator light's on or off status. Let's keep this core requirement in mind first. All subsequent actions will be based on it. Then there are the mission goals, falling into three categories. From a knowledge perspective, be able to master TIA portal installation, PLC programming, touchscreen interface design, and debugging, as well as understand common bit logic instructions. From an ability perspective, be able to perform hands-on tasks, install software, program and download PLC, and create, download, and debug touchscreen interfaces. From a quality perspective, be able to cultivate the habit of taking care with small tasks, as well as teamwork skills. These are important qualifications in the field of industrial control. Let's start with the relevant concepts. The first part is the integrated development environment. The commonly used is TIA portal, stands for Totally Integrated Automation Portal, referred to as TIA portal. It can configure PLC, HMI, and drives in the same environment, which greatly reduces connection costs and debugging time. In addition, WinCC is a tool to develop HMI. S7 PLC Sim is PLC simulation software. These tools allow us to practice when we don't have the physical hardware. Let's take a look at the version timeline. From v10.5 in 2009 to v17 in 2021, TIA portal is constantly being updated. We'll use v17 this time. To learn how to use TIA portal, the first step is to install it. There are three things to be done before installation. First, to confirm the system requirements. Windows 10 or 11, 64-bit Professional or Enterprise Edition, CPU, at least i5 divided by i7 3.0 GHz, RAM, 16 GB or more. Hard drive space, 32 GB of free space is recommended for complex projects. Hard drive type, SSD, with at least 100 GB of free space is recommended. Graphics card, support DirectX 11. Administrator access is also required. Second, download the installation package. Download the v17 ISO image from the Siemens official website or authorized channels. Load it using a virtual drive or extraction tool. Third, install the dependencies. Ensure.NET Framework 4.8 is installed. SQL Server 2019 is included with TIA portal, but checking compatibility is required. There are 4 key points to note during installation. First, turn off antivirus software and firewall to avoid interception. Second, the installation path must be in English. It will cause errors if in Chinese. It is recommended to use the default C drive path. Third, if Net 3.5 SP1 is not installed, you will be prompted that components are missing. Install this first. Fourth, to avoid multiple restarts, delete the pending file rename operations registry entry. The path is shown in the image. Next is the installation of the S7-1200. A 35mm DIN rail is required. It supports both horizontal and vertical mounting methods. Regardless of the method, ensure there is enough space, with at least 25mm on the top and bottom, and at least 25mm between the front and the cabinet wall. This is for heat dissipation and future maintenance. This step can't be skipped. Then, check the wiring. Taking CPU 1214C as an example, it has 3 types. The focus in wiring is on the voltage. DC-DC-DC, power, input, and output are all DC. AC-DC relay, power is AC, input is DC, output is AC-DC. DC-DC relay, power is DC, input is DC, output is AC-DC. Before wiring, make sure to identify which type you're using to avoid incorrect voltage connections. When wiring, also pay attention to the 1-meter terminal. There are 2 wiring methods, common negative and common positive. It is clearly marked in the drawing. For example, common negative means connecting the 1-meter terminal to the negative of the power supply. Common positive means connecting to the positive terminal. This directly affects the input and output connection. Make sure to connect according to the diagram. Next, let's move to the basic bit logic instructions. PLC programming requires knowledge of basic bit logic instructions. Let's start with 5 of them. First, normally open contact, close when the bit is 1, open when it is 0. Second, normally closed contact, open when the bit is 1, close when it is 0. Third, negate RLO, when the left side is 1, the right side is 0. When the left side is 0, the right side is 1. It can reverse the energy flow. Fourth, coil, when the left side logic is 1, the coil bit is set to 1. When it is 0, set the coil bit to 0. Fifth, negated coil, the opposite of a regular coil. When the left side is 0, the coil bit is set to 1. When it is 1, set the coil bit to 0. Now, let's move to the usage of 3 types of logic operations. And logic, for example, when both I0.0 and I0.1 contacts are closed, 1, Q0.0 will output 1. Or logic, when either I0.0 or I0.1 is closed, Q0.1 will output 1. Not logic, for example, when I0.0 is closed, Q0.2 will not be closed. When I0.0 is open, Q0.2 will be closed. This is the negation effect. These are the basics of programming and must be understood. Now, let's move to task implementation. Take a look at the reference solution first. There are 4 steps. First, hardware wiring. Connect the DC 24 volts power supply, SB1 on, SB2 off, and HL indicator light according to the drawing. Second, PLC configuration programming. There are 7 steps from project creation to monitoring and debugging. The core is programming to control Q0.0 indicator light. Third, HMI configuration. There are 9 steps from adding the touchscreen to joint debugging. The focus is on button association M10.0, M10.1, and the indicator light association with Q0.0. Fourth, physical control. Whether pressing the physical button or the touchscreen button, it can control the on or off of the light. This is the final result. During implementation, follow the following 7 steps. First, install the TIA portal on your own computer. Second, create a project in the TIA portal and add hardware such as PLC touchscreen to complete hardware configuration. Program the PLC and download it to the PLC. Fourth, simulate and debug the PLC program in the TIA portal. Fifth, create the touchscreen HMI human-machine interface and download it. Sixth, simulate and debug the PLC program and touchscreen together. Seventh, physical wiring and debugging for LED light control. Beginners are advised to start with software simulation and move on to the physical setup after becoming proficient. After completing the task, an evaluation is required. Refer to this table for the standard. Teamwork, 20 points. Evaluate the discussions, planning, division of work, and initiative. 7S management, 20 points. Evaluate the organization of the environment, item management, safety, and cost awareness. Professional ability, 60 points. Includes theory, ability to explain steps and methods, and practice, ability to assemble, program, wire, and debug. You can refer to the standards and perform a self-check. It also helps with group peer evaluations. Finally, let's summarize. Today, we learned about the environment and installation of TIA Portal, S7-1200 installation and wiring, basic bit logic instructions, and the programming, downloading, and debugging of PLC and touchscreen, as well as physical debugging. These are the basics of Siemens PLC development. I hope you all practice more after the course and build a solid foundation. That's all for today. Thank you, everyone.